So the YouTube interface tells me that the event is starting now. I'm skeptical, so give me a second. Wait till I see something appear on another screen so I can believe that it's really true. Because it would be a pity twice in a row to think I'm live when I'm not. I have to upload offline. Excellent, it's working. Hi, here we go again. So what we're doing now is we're continuing with something that we started on in the previous stream, which was so-called Twitter-driven development. So we saw a cool script posted on Twitter that runs perf, the Linux performance monitor, and does some post-processing on its output to generate a report of the distribution of times that the system calls take in a program, and prints these in a report with backtraces and some statistics. So it's pretty neat, and what we did last time is just get it running on our development machine, which took a little bit of effort, which is not that surprising with code that you're kind of copy and pasting off Twitter. So probably with about the expected amount of fuss, we got it up and running. But what we want to do now is integrate this into Studio, and I won't go into that because we covered that in the previous stream. So we'll just dive in. So the thing that we need to do now is go from having it running in an interactive bash shell on our development machine to having a Nix API underneath, or a Nix API that we can use to run it. And I thought of a small complication, which is that the perf command needs to run as root. And Nix ordinarily doesn't let you run things as root because it does builds in a sandbox. So we got two options. Either we can, within the sandbox, we run it in a VM with QEMU, but that's not very appealing because this is performance work. So you know you can kind of screw everything up if you do if you change the execution environment too much. So what we'll do instead is we'll find a command line argument that makes it possible to. Sorry, you can't see my screen with the tweet. We'll find a command line option that makes it possible to run things as root. We'll just selectively disable a little bit of the sandbox. So here's the tweet that we're implementing from. There's a link there which goes to this script, which we have up and running, that prints system calls that were made, the backtrace that led to them from user space, and how many times they were called, and their statistics and stuff. So let's remind ourselves what our goal is here. We want to have a little API where in the Studio IDE, it's only the leftmost panel that's relevant to us now. We want to be able to write things like perf.syscalls find or we want to be able to write perf.syscalls and then some command in there, and what we want is that the command runs and it gives us a report, initially that ASCII one, and we'll try to make it a bit fancier if we have the time and energy. So let's have a look. Here we are back in our shell. We can go back up, see what it looked like when we ran it. Okay, and while we're here, we noticed a portability problem that we haven't resolved yet, which is that there's this header file that the awk script wants to load to get the mapping from system call numbers to symbolic names, and the awk script has a hard-coded location, which is probably fine for most Linux distributions, but it's not okay necessarily for Studio, which is running. We don't know what machine it's running on, and on the development machine we have a Nix source which doesn't have anything of that path. So we need to deal with that dependency in a good way on the way through. So let's start programming. We will want Emacs. So here we are in Studio. We check out Studio from Git, and we have a backend directory which is all of the Nix APIs for building and acquiring data to inspect. So we have, for example, the Raptorjet folder there for running and pulling in Raptorjet data, one for Snab, things for processing dwarf debug information, simple hex number for binaries. And what we're going to do now is add a new one here for perf. So we'll create a perf/default.nix, and we'll model this on the Raptorjet one. So we will just say perf Nix library API, and we said we would have perf.syscalls command which will execute Unix command and profile syscalls with perf. Simple enough, right? This is what we want to implement now. We're going to have this this next command. So we'll give it a pretty standard preamble. Just copy that over from here. And we're going to return a set of key value attributes. The key is going to be a name. The value is going to be a function. This is going to be our API. We're going to return attribute called this module is going to this is constructing a module here, and the module is going to be called perf, and the function is going to be called syscalls. This first function that we implement. So syscalls is, and it's going to take a string, command string as an argument. And what's it going to do? So we'll keep it simple to start with and just do this all in one derivation, but longer term, obviously, we're going to want to have a separate way for producing data and consuming it, because you might very well want to produce the data somewhere far, far away, or maybe you've already done it a long time ago. Maybe you have some recorded perf data on your disk somewhere and you want to analyze it. So of course we would want to be able to decouple the production of data from the processing, but that can be step 2. For now, we will run a command. Command will have a short name of perf syscalls. We will need to specify the build environment that we want. We're going to want to have some so-called native build inputs. We're going to declare the software packages that we want to have available when the script runs, and the Nix environment is then responsible for giving us the standard pinned version of each one of these packages. So anything that we declare here is software that we will have in our path, and the exact version of that package, and the compiler it was compiled with, and the libc that it was linked with, and everything will be implicitly defined by our Nix code here. So we're going to be isolated from funny things happening, or anything that might be on the host system. It won't matter what Linux distribution you're running this on, and so on. So what do we need? We're going to want bash, possibly is included by default. I think so, but anyway, we're going to want see what the perf package is called. Just a moment. Yeah, I want Linux pages.perf, and what else? We're going to want awk. Awk, GNU awk. Yes. Awk. And we can add stuff there if we've got anything, but this is one of the differences between Nix and make, right? So if it was make, you would just have to kind of hope that stuff was there. Mostly you would assume that it was, and you might have a separate, horrendous autoconf script that goes off and tries to find paths and print errors and all this kind of stuff. With Nix, you just kind of specify what the environment should be, and then Nix is responsible for making it so. So the script will only run if this environment has been automatically created, and then we're gonna write a script. How do we want to indent our code? It doesn't really matter. Syntax for a multi-line string. And what are we going to do? So we have to use sudo in here. I know it's going to give us an error, but we'll deal with that when the time comes. What we're going to do is we're going to run the same commands that we did basically out here. So we did a perf record, we're going to run sudo perf record, and instead of hard coding it find, we're going to splice in this command string that was given as an argument to next. So we'll do perf record, and then I'll have that at the end. And I don't think that any extra quoting is needed there. Imagine that that's going to do the right thing. So this is execute the command with profiling, and then just keep it simple. Oops, this directory we're in, so that it can do its autosave. Okay, so that's going to run the command and give us the recorded perf data. Then the kind of the important side effect of this script is actually to construct a directory called $out. In fact, maybe we'll just do everything there, because anything that we put in this $out directory is going to be available as the output. I guess we would like to have the raw data there as well. So the first thing we're actually going to do is we're going to say make $out and cd $out, so that we do everything in the directory. So any local files that we create are going to be here, going to be available in the output. So that's going to include the raw perf data that is created as a side effect of that. And now we'll post process with awk script. And how do we do that? So we ran this with sudo. I mean, I guess because the perf data was created by root, so it's probably only readable by root. And you know, we could chmod it or whatever, but we don't need to. We will break that pipeline up a little bit. And probably we'll call this report.txt. So we're gonna just run the commands we did before, just split it up a little bit. It's going to go into report.next. But the thing is, here we're talking about perf+syscalls.awk, so this is going to have to be a file that actually exists, and so this code is going to execute in the output directory that we've created here. But we're going to want to reference a file here relative to the source. We're going to have it in the source tree in the same directory as this file. So the way that we do that is with this special syntax that evaluates the next code and splices the result in. So we're going to say that we want to do it with /perf+syscalls.awk, and this is going to actually this is going to get spliced into the bash script that we're looking at before it runs. So we can put that. We just need to create that file in the same directory that we're in now. So I think it was up here that we had it before already. Yeah, so we'll just copy that. So there is some possibility that this would work. Nothing ever works the first time, one hopes, because it's always very suspicious when it does. So we can give this a try. We're obviously going to hit an error on sudo, but we'll that'll be the next step, will be to get that error. So let's try running that. So what we're going to do now is we want to call our nix function, see what happens. Let's say nix build. In the latest version of Nix, they've unified the command line interface in a new, really nice one, but that's not the mainstream release yet, so I don't have that. So I'm using the kind of the traditional Soon Legacy interface, and it's got a lot of different commands like nix build, nix end, and so on. Their arguments are always a little bit different, so I'll always scratch my head a little bit when I'm switching commands. You want to run an expression, which will be perf.syscalls, and let's just do something simple like find dot. And actually that's already a little bit tricky because we don't necessarily have find in our path, but we'll get that error and then we'll deal with that. That looks fine, and then we need to tell it that we want it to use the package definitions from the current directory, and I think we can just do that, can we? No. So I need to tell it that I want to use the Nix code we have in the current directory. Oh wait, I think we have two problems. One is I need to tell it which Nix code to use, and the other is I need to actually load and import that. Here. Okay, let's do it all in code. So we're going to run a Nix expression. The first thing it's got to do is say with import current directory. That probably is enough to load all of our code. Let's see. So we got somewhere. We got a small step forward. So what happened? We asked Nix to build an expression. And the expression first imported the Nix code that we have in the current directory, which should give us our definition of syscalls library, and then we tried to call perf.syscalls find, and we got an error, attempt to call something which is not a function but a set. So this is actually interesting. I often have type errors when I'm programming in Nix, and I find it a bit tricky, and I often spend time scratching my head and trying to figure it out. And what I'm wishing for is not actually a type checker, but is rather a pretty printer. So when I get an error saying I've supplied something that's the wrong type, I would like for Nix to actually just print what it was. So instead of telling me that it's a set, could it just print the set, tell me what keys and values it has, so I know which set it is, and I can say, aha, that was the problem. But I don't have that now, so I'm going to do a bit of guesswork. And it's kind of nice, well, for me to doing it on live coding makes me a little bit more conscious of what I'm doing. So this is something I should mention to Nix upstream and see if there's some clever trick that other people have, or whether it's potentially a feature that could be implemented and so on. Anyway, later. For now, why did it get... well, first of all, I haven't hooked this in anyway. This is kind of I created this Nix source file, but I haven't linked it into our package repository anywhere. So to do that, I need to actually come up a little bit. I think I have it in here. So that's at least one problem. I need to hook it in and say that when we say syscalls, we are talking about calling a package. No, when we talk about perf, we want to do that. So I'm not sure that really matches the specific error that we saw. No, but that's something that needed to be done. So if I would say instead raptorjit.run to see if it's a problem in my usage or my implementation, if I say raptorjit.run script, and what would happen? I get the same error. Okay, so it's not something in the code particularly. It's something I'm doing wrong already. Can it be as simple as that? Yeah. Yeah, I didn't import the package tree in the right way. So that's actually running Raptorjit, and those that readelf stuff is from some dwarf parsing happening in the background. Never mind that. Let's go back to what we really want to do, which is do syscall profiling on find, and we'll do the same fix there. Take away the unwanted empty set. So what is happening now? It downloaded perf, the same version that's referenced in the Studio repository. So everything is pinned. So it went off and grabbed the pinned one, and it said sudo command not found. Okay, so probably the easiest way to get out of that is to just turn off sandboxing. So the best way, and something I need to come back to in Studio, is to actually pass a sudo binary into the sandbox so that we can run that. And of course, we need to think about the implications of that, but it's kind of an important thing in many contexts to be able to run things as root. So we'll always want it at least as a good option. But for now, I'll just see if we can just turn off sandboxing at the possible risk that it'll make some that it will allow us to run some software that we don't actually have correctly declared. But we'll just take that risk for now, and we'll fix the hygiene a little bit later. So where was I? I was going to Google how to turn off sandboxing in Nix, which I did. Nix disable sandbox. Minus option build use sandbox. Let's see if that could work. Still didn't have sudo. Maybe that's a path issue though. So there's another reason we're going to want to do this neatly. We're going to want to pass sudo into the sandbox, and we're going to want to do it either in the path or at some fixed location so that we don't have a dependency on where the host machine has sudo. But we're going to treat that as a nice to have for now. Okay, we were using sudo twice. Let's do this. We'll say so we're using sudo more than once. So I'll put it in the path. Why did it spew all that binary at us? We're not trapped the output properly, perhaps. Let's have a look. How did we run it on the command line? So I think maybe we got a lot of binary junk in our shell when we did that. Maybe it's that perf is checking whether it's talking to a terminal or not, and changing its default behavior. So maybe we need to force it to output to a file. Let's see. perf+log we'll call it. So that's what I think has happened, is that when we run it and we're not in an interactive shell and we don't want to get the output printed dumped into the standard out, we need to say and when we do perf script. We need to tell it the input name. That's I. Any chance that this could work without dumping everything into our terminal? And we've got a usage error. Why? Perf record was not happy because we missed line continuation. Let's try that again. Okay. So what do we got? We got some warning messages that may or may not be important. We got another warning that we're already conscious of. We already know that we need to fix. And then we got an error where it kind of looks like Nix was not very happy with our trying to put a file owned by root in the output, if I would understand correctly. So what's the easiest way to reset the ownership? Not the permissions, is it? It's the ownership. I'm sure that Nix has a standard library thing for this. Let's just have a look. Although it's going to happen as root. So what's who am I for group? Suppose we ignore the group for now and see if it helps. Let's just say see if that helps. Probably not enough. Probably the group will be illegal, but we'll see. No, it was enough. Wow. Okay. So that Nix script ran, and everything as a result went into this output directory, where that prefix there is the SHA-256 of everything that we depend on. The version of awk we have, the version of perf we have, the version of libc we have, the version of gcc we have, and everything. So that uniquely corresponds with that combination of software dependencies. And also we get a symbolic link in the current directory result, which contains our stuff. So in that we got the perf.log, which is the output from perf, and we also got report.txt, which hopefully, let's see, is actually our awk stuff. Yeah. So, but you know, actually now it starts to get interesting. It may even be that we could put this into the GUI now and start playing with it. So that would be a cool milestone. So let's actually try that. I'm going to need to start a new GUI or restart the GUI because now I ran it off an installation that I made. But now what I want to do is I want to run the backend code straight out of the directory here. So when I edit things in the local checkout, I want that to immediately be visible to the UI. So I just need to set an environment variable to tell it where to look for the Nix code, so it looks in the checkout rather than the installed copy. So we'll just do that. And that's how we do it. And we had VNC display 42 before. We'll leave that running and we'll do another one on display 43 because, you know, hey, it's a server. These processes don't take any meaningful memory these days. We'll fire up a VNC viewer. And here we get here we get our little GUI. So could it possibly work? Is it in any way plausible? If we say perf dot, if we say syscalls find dot, and then click the green run button, something is happening. Ah, okay. So this is something I was waiting for to bite me. So actually, I mentioned that I've been focused on getting the Studio to support Raptorjet really nicely, and it's kind of extreme to the extent that everything that gets built is assumed to have a Raptorjet log in it. So I need to fix this in the front end right now, so that you can build things that that aren't Raptorjet processes. So what happens? Studio Inspector. At the moment, when I do a Nix build, I'm always turning it into I'm always building with Nix and taking the first output and then making a Raptorjet process out of that. But well, let's just take the quick path as well. We'll need to fix this when we merge, but let's just treat it as a normal directory for now. See if that can possibly work. Yeah, right, okay. So now, what happens if we click here? Well, then we've got our little report, actually. So now we have it in the GUI, and I can scroll between the panes here. I'm only on 720p, so I don't really have a lot of screen width to be showing everything at the same time. But there's our little report. The awk code is running, and we should be able to do things as well. So here I'm doing the current directory, and it's a little suspicious that find was in my path. It might be because we disabled sandboxing. It might be that I should have referenced that in a different way, but we can find an example of how to do that too. But first, let's say it's not the current directory is where the build is happening. There's almost nothing there. Let's suppose we wanted to look for some files we're interested in actually. So the awk file is referencing a kernel header, which is not finding. So so we have this problem over here that before that equal sign, that number is actually supposed to be a symbolic name of a system call, and at the moment it's not. It's just a number, and the problem with that is that the awk script can't find a specific kernel header file that it's looking for. So we need to start thinking about how we find the kernel headers on disk, and we can demonstrate that here. If we find on the kernel headers, we can say do one of these string interpolation kind of things with Nix, and we say, well, let's see what they're called. I won't guess this time. Kernel headers, Linux headers. Yeah, Linux. Yeah, Linux headers. Ah, yeah. So if I say this Linux head, so that it's a little bit hard to see. I probably need to increase the font size, but hey, I'm already struggling with width as it is. So it's a $ and then curly braces, and anything inside there is going to be evaluated in Nix and then spliced back in. So when I reference Linux headers, it should go off, fetch them if needed, download them, put them in a path on disk, and then this will expand to that path. So what I'm expecting here is that it's actually going to run find over the kernel headers. And again, I apologize that I haven't got a good I haven't got a nice GUI for the Nix builds yet, so we don't see it going off and downloading the headers or whatever it is it's doing to build them. But we'll just be a little bit patient, and another time we'll come back and we'll put a really nice interface on the Nix side of things there. It's actually a little bit hard to be patient because there's a bug with the front end when it runs sub-processes like Nix. It does occasionally get stuck and need a restart. It doesn't happen very often. I would say it normally happens less than once a day. But if it sits there like this for a while, then I got to ask myself: is it because I don't have any progress information, right? I haven't implemented that, and so I don't know whether it's stuck or not. I'm going to take a sneaky peek with top and see whether Nix is doing anything. It's not. Okay, so actually, I think the UI has got stuck. It's unfortunate for a demo, but these things happen. So we'll just restart that. We'll copy paste what we had there, hit it with an interrupt, copy and paste this out to the safety of Emacs on the host. And restart. A great topic for a future episode would be to track down this issue where Pharaoh spawning subprocesses, at least in the VM that I've built, gets stuck after a while. We'll kill VNC display 42, which nukes that process. We'll start it again. We will open it again with VNC. Go back. We will copy and paste back the line of code we had. And we'll try running that again. Now I need to reapply that same change that I made. It was so simple that I just do it interactively. I didn't save that anywhere. It was simply that. Oops. Okay. So now we have it again, and now this is from running running find on the kernel headers. So okay, find is not that exciting, but we've got to figure out what to do now. So it would be nice to do another cool example, but maybe we put first things first, and we put the symbolic name of the syscall in here, and then maybe we try and do something new with the data as well, and then we worry about finding more interesting examples, because okay, this is still just text stuff, and we let's do something graphical. Let's make it easy in the meantime. But this Linux headers thing I want to fix. I want to have the symbolic names of the system calls. So let's get that. So I need to remember there's a feature in Nix for in scripts like our awk script for substituting in hard-coded paths with something appropriate at build time. And I know there's a project called Stix that uses this feature where I've seen it. And I'm just gonna go there and see how they did it to remind myself, and then we'll steal that. It's the Nix code. It's there. Stix.shell. Yeah, this thing where they have @ signs around what I think is just a Nix expression, and then they somewhere have some code that was a substitution on that. We're going to find that. It's going to be a substitution on Stix.nix, Stix.shell. There. Here we go. Substitute all in place. Sounds like a thing for us. Okay. Here's what we're going to do. We go into our awk script. And here we have this. Okay, so I need to figure out what is the kind of what is the name for that prefix. I'm just going to take the easy way out and just search my disk for where that file is. I'm sure that Nix has a command for searching and asking which package was responsible for installing a file with this name, but I don't know it offhand, so I'm just going to violate that abstraction boundary and just search in the on disk cache. There we have it. Okay, Linux headers /include /asm /this. So we're going to just change this to Linux headers, what we had before, /include/asm. And then before we run this, we need to do the substitution on it. So we'll do that. Now, I think we're going to want to use something called substitute all. I'm just going to search the standard Nix package definitions somewhere that's already used. So I don't think we need to do this in place, right? We're quite happy if okay, so before we were just running out syscalls.awk here. Now, inside these curly parentheses, it is Nix code. So I'm just going to say substitute all. That's going to be the source. And we need to provide a destination. Can't it just? But we'll do it like this. We'll make it an input called perf+syscalls will be substitute hang on. Need to look at the example again. Okay, so actually I was thinking that substitute all in place was a Nix function, but it's not actually. It's something that's defined in a bash environment that we have there. So so we're going to do this in a different way. It's not going to be in the Nix code that we do the substitution. It's going to be in the bash code. So what we will do is we'll say copy from the relative to the source tree syscalls script into here, and we'll say substitute all in place of syscalls, and then we will run this off the local copy. So there's some chance that that's right. Let's see, we can do this in the GUI. Why not? Well, why not? It's because it's dreadful to debug if it goes wrong, but if it works the first time, it will be fine. So what we're hoping now is that we don't get the warning, and we do get the system call names instead of numbers, symbolic names instead of system call numbers in the dump. It's kind of masochism. Let's do this in the shell. We have a fully working development environment for Nix. Run it the same way that we did before. Okay, no, it didn't work. So it kind of looks like the substitution didn't happen since cat is seeing this Nix headers. Called kernel headers, was it not? Linux headers, is that what I said? Script, Linux headers. Linux headers. double check the example again. Misunderstanding. Is it using this in other places? Seems kind of consistent with our usage to me. Spend a little another couple of minutes trying to figure this out, and otherwise we'll live with the syscall numbers for now. I mean, I guess this is one of these things, you know. Nix, I'm still a relative newbie, and I guess the more you use it, the better you get. And it's kind of solving a real problem here that I don't particularly know how to solve otherwise, you know, except with, heaven forbid, something like autoconf, which is to actually find appropriate header files to build with. So it's worth spending a bit of effort on it. There is a payoff here. I'll just get it to cat that script so that I can see with my own eyes what's happening. Linux headers is not being... maybe that's not visible. Maybe we need to import the Linux headers. Maybe it's not in scope at the next level, so it's not being considered for substitution. Did that look any better? Yeah, okay, that's what we were after. So now the code that actually runs, it flips out and it automatically grabs this file from the right location. So again, when we run this, it's always going to use exactly the version of this system call definition that's specified in these Nix build scripts. So if you would run this on your machine, regardless of which distro you use, it would use the same header here. And an interesting question actually is whether we want to take the default version of this header or if we want to do anything special. And I think for now I'm pretty satisfied to take the default one, but it would actually make sense to make a little bit of effort to use the latest one here, to take it from the unstable, the latest. If the Nix packages has a bleeding edge kernel, we should take this from the bleeding edge kernel, because system calls are famously backwards compatible in Linux. So it shouldn't be a problem if this file is too new. But if the file is too old, then it will be a problem in that there might be some system calls that it doesn't recognize. We might miss the names of those. So it seems like newer is better, but it also seems like contemporary with the other packages is good enough for now. So I'm pretty happy with that. So now if we flip back into the GUI, which is seems to have gotten stuck again, which is actually really interesting, because if I could reproduce this problem more easily. So on the one hand, it's annoying that it's got stuck now twice in the space of like half an hour, when I am accustomed to it happening kind of twice a week. Maybe we're actually on the track of making that more reproducible, which would be really cool. So it's worth spending a bit of time on that too. But for now, let's just do exactly as we did before and just restart. Restart the Studio on the same VNC address. Pull up the viewer again. And now when we run our script, with any luck, we'll see symbolic names instead of system call numbers. Let's have a look. That's Emacs. Here we are back in Studio. We give it the thing that we want to run find over all the Linux headers. Give it another 10 seconds before we look in top to see whether we're waiting on Nix or on the UI not being able to run a sub process. Interesting. So Nix isn't running there. Okay, so we seem to have stumbled upon a way to get the front end wedged, waiting on something. And come to think of it, I didn't fix that thing in the debugger that we had to fix the last time, which we really should. I really should, but I just did it with an interrupt. Yeah, so it's waiting on a subprocess. Okay, so I'm just going to just persevere with that for now. Just do it again. But maybe not for you that has to watch this, but for me it's actually nice to think that I have potentially found a way to fairly quickly reproduce that problem, or at least I'm on the track towards understanding it. To our viewer again. Try again. If this fails, we'll invoke plan B. Let's see what happens. Okay, that's the error that we had before. Should fix that on the code. I don't really have a really good way now for. I mean, we're changing the Smalltalk code in the front end now. We probably should update this to be able to load patches automatically at startup. I haven't done that yet, but then we could just write this patch into that and have a locally hacked version. For now, I'm just doing it again. Doesn't take that much time. Okay. And now we've got an extra file, which is the syscall script, because when we did the substitution, it ended up in the build output directory, which is kind of harmless, but unnecessary. So what do we got in here? Do we have symbolic names, or do we have? Yeah, now we've got symbolic names. Okay, so it's a bit plus and minus. It's causing the lines to wrap. I can make the window a bit bigger so that doesn't happen. Okay, yeah, so that worked. Now we see what the system calls were. We see we've got a memprotect here, memmap, fstat, everything. So, okay, so nice. So now I think that this is actually the output that we're supposed to get from the awk script. Okay, so there's some niceties that we should do. We should make it print that header that we saw in the original example so that we know how to interpret the columns, and we should also figure out how to render that in a fixed font. But let's try doing something cool first, because I just want to do something graphical. I think I'm going to be satisfied if we can just do something a little bit graphical here. I'll be happy, and then we can use our imagination and have something to go forward with. So what I want to do is get this awk script to kick out some CSV data. We'll take a break before we do this, but let's organize our thoughts. We're going to get the awk script to kick out some CSV data. So instead of just these summary statistics, we get something that's a little bit more raw, and then we're going to just feed that into a little bit of an R script to do a ggplot graph that looks pretty and gives a little bit of other context to this data. Should be nice. So we'll do that in 10 minutes because we've had a kind of a good slog already. Back then. All right, so let's just jump straight back into it. What I want to do now, we've got the perf recording running, we've got the awk script running to generate the ASCII report. We've got it all hooked into the graphical studio interface. What I want to do now is just get something graphical. It'll be satisfying. It can be a very, very first step towards doing something more than what the script was already doing. So I've already pulled up the awk script, and what I want to do is get it generating CSV data as a side effect of what's already doing. Right, so let's just jump straight. We're already running the script over the data to generate the ASCII report. Yeah, I'm going to make it generate CSV as a side effect of that, and then we're going to do another step to do something with the CSV. We're going to hit it with R. So this seems to be the appropriate place to hook the script. It's almost never that I edit somebody else's awk code. I had a lot of my own awk code, but anyway, this is very kind of nice and approachable and easy to understand, it seems. So all we want to do here is put in a printf, which is going to print a little bit of CSV data. We'll keep it simple. We'll maybe throw away the stack data. We'll just get the what system call was it and how long it took, and we'll do something with that. That's fine to start with. So we want to print a number. No, it would be a name, the system call, I hope, followed by, I guess, a floating point number, and a new line, and the name will be syscall TID, and then we'll have the elapsed time, and this should go into, sorry, in awk, is it one of those or two of those? I'm going to assume it's one. We'll go into syscall time CSV. Could that possibly work? Let's have a look. We'll try running that. Something happened. If we look in our result directory, syscall time.csv. Does it look plausible? Yeah, okay, that wasn't so hard. So now it seems like we've got the individual samples. Okay, there's not very many of them, but that might be because our example was too trivial. Hold on, let's just make it slightly, ever so slightly less trivial. What did we do before? I'm fine over the Linux header, so it makes a few more syscalls. How many entries do we have? 800. Okay, so presumably if we would run this on something bigger, we'll get more samples. But this is fine. 800 and something seems fine to begin with. So let's add a little bit of R code here. So the thing I like about this is R is a cool tool. To do cool stuff with R, you normally have to depend on some other libraries. If you depend on other libraries, your life is miserable because of the dependencies and the dependency versioning and dependency hell. And in the studio environment, that's taken care of by Nix. So if whatever I do here, any errors, if I get an error, you'll get the same error. If it works for me, it'll work for you too. And provided we eventually put a test case in here, then we'll be able to see when we update software packages whether it breaks anything, and we'll be able to track those down. So it will be glorious, but that's all for later. Now we're just going to get something working. So where are we already using R in here? This is one place. Just see which packages we need to get. Because we're specifying our software environment that we want to have available, we need to declare we want R and which specific R packages we want. Where were we? Here. So with here. We want R, we want, there's probably a tidyverse collection, but I'm just going to name a few that I know that we want. That should do. And then after so here's where we run the awk script, and at that point we should have the CSV data already generated. So say here at the bottom we can generate an R report. Let's keep it really simple and just even do this inline. Let's say our script what are we going to do? We're going to want to get our ggplot2 library, and we're going to say that our data is read CSV. What do we call it in the awk script? Syscall and hey, let's just print the data and see if that works. And we'll say our script, avoid confusion. See if that can possibly work. Find function reads it. Okay, load all of our dependencies. Let's do that. Load them all in case we want them. Try that again. Now we got some kind of a more interesting error. Syscall underscore time CSV doesn't work. It was a hyphen, wasn't it? Fine. Now, okay, now we just printed a message to the console, so obviously there's some data there, but now let's actually generate a graph, eh? That would be cool. I'm going to pick an ECDF, an empirical cumulative distribution function. It's a graph that you can extract a fairly good amount of information from this data set, I think. We'll generate it first and then we'll look at it. So we're going to want to say ggplot our data, and we're going to have an aesthetic where the color is going to be, we've got to give that some columns, don't we? May as well just do that. Hold on one moment. Let's pull up RStudio and just check how we specify column names, because we neglected to put them in the awk script, and that maybe is overkill. Read CSV. We'll swap in, and hopefully this doesn't kill my video stream because it's got to encode on the same machine that is now swapping in RStudio, which is a hard disk rather than SSD. Don't ask me why I made that purchasing choice. Okay, so we want to tell it not to pull the column names out of the file, actually, which would otherwise presumably be, sorry, read.m, read CSV. We don't want it interpreting the first line of the file as being column names, because it's not, although, you know what, maybe we just put the column names in there from awk, and then the R side will be automatic. Let's do that. We had something at the beginning here. Let's just say printf syscall elapsed. Let's put microseconds. Microseconds is fine. Okay, so now we're going to have those column names in the R code. So the color is going to be the syscall, and the X position is going to be the microseconds. And because of the kind of graph we're generating, the Y is kind of implied. I'm going to do stat ECDF. And then was it GG save to save the most recent plot? Let's check. Just wrong window. Yes. GG save syscalls ecdf.cpng. Well, let's see if that can possibly work. Nope. Syntax error in the awk script. How about a semi? It's not very fussy about semicolons. Is that really what it wanted? That is what it wanted. saving an image. Oh, we still have the printout, but whatever. ls result. We have a PNG file. So now in principle we can rerun that in the GUI, and if it doesn't get stuck, as it often has, in which case we'll have to be patient and rerun it. But if it just works, then that could be pretty interesting. Let's see. Let's see if that's actually running now. A little green button disappeared. So that's also something that's happened when I go in the debugger, the UI debugger, and exit out, do abnormal terminations, interrupts, and stuff. Then sometimes I lose my little green button, and then I just quietly use a hotkey. That seems to be stuck again. So good news, bad news. I'm very easily reproducing the problem of the UI getting stuck. Bad news. Got to start it again. But you know, the last time. Any luck? It's the last time we actually. Well, let's not get ahead of ourselves. Let's see if there's anything sensible in the graph or not. So we kill that process. Start it again, as before. Being very patient. Open it up again in VNC. And pull up our little script that we have there. Swing that out a little bit. And we do a drum roll and we hope that that's working. Okay, there's the same error as before. Again, we very patiently just do the same patch that we did before and remind ourselves that we want to have an easy way, a really super easy way to just dump all of the, dump any changes that we've made in the front-end code and have that automatically loaded again on the next startup. I think this is trivial, but I'm not going to do it right now. So we do not, so what we're doing here is removing this hard-coded assumption that whatever Studio builds is going to include wrap-digit logs. So what actually should be done here is we should take a look at the directory. We actually have a file that says what the file type is. Anyway, we're going to automatically detect what the appropriate thing to do is there. At the moment, we're too caught up in the enthusiasm of wanting to see a pretty picture. Here we are. What do you think happens if we click on that? Ooh. Okay, so you know, sure we can. Do we want to press our luck and redo that as SVG, or do we just want to see what goes on here? You can scroll around. It's almost of a reasonable size. Yeah, I'm going to push my luck and try doing it again as an SVG. Because I've been wondering actually how well SVG is supported in the Studio frontend, in the Smalltalk code, because normally when I use R, I mean, you've got a choice between doing the PNG, which is a fixed size, doesn't scale all that neatly, or doing the SVG. And at least when you're using web browsers, I'm sure it's the same here, a lot of the time, if you end up having a lot of visual elements in your SVG, you end up kind of blowing up your whole computer just trying to open the file. So I don't think it's going to be a problem with this specific graph. So give it a try. So when we do that GG save, we'll do it again. And I'm going to assume that it's detecting the file type of the file name. We'll see. Let's try it again. If it gets stuck, then that's on me. Run it again. Okay, it's not a very good ad for the front end when it's getting stuck so much. I got to fix that bug. Maybe we'll do that on the next approach, which would be nice. Then we're kind of looking into the Smalltalk VM. Anyway, let's just cheat right now. Let's load the SVG in a browser. Is it cheating too much? No, that's okay. We just want to see the picture now. Copy it across. SVG, shall we? PNG. Simple. Let's have a look at what we got. So this is it in the screen a bit more nicely. It shows the dimensions that well. Anyway, we're gonna make do with this. So this graph, it shows all of the system calls that we made, and here you can read this as a percentage and kind of as percentiles. So if you're wondering what system calls took more than 50 microseconds, it looks like the only one that did is this green one. Okay, the colors, it's a bit hard. Well, we got a picture out of it anyway, so we probably want to improve this quite a lot. When we're saying that, let's just hop back in here anyway. So we now have our GUI set up so that we can write a little, we can write perf.syscalls and put a command, kind of an arbitrary command in here. It's going to get profiled with perf. It's going to run the awk script with all the appropriate dependencies. So once we check this in, you won't have to do it, or nobody will have to do the kind of stuff that I'm doing, that I was doing with tracking down the dependencies and everything. It will be automatic. You'll get the report. You'll get the report from the awk script that gives us some statistics. We can improve that slightly by putting the headers on, and we'll get the graph where we can then see in a bit more detail kind of percentiles and that kind of thing for each of the system calls in this case. And we're going to have to be a little bit more clever about that, because it's a little bit too much information to have in one place, and the scales are also not necessarily appropriate. Actually, it's kind of okay there, but we can think a bit about that. But kind of the sky is the limit now, right? Because with ggplot, it's the easiest thing in the world to kind of come up with ideas for things that you want to try and mess around, and you can do this interactively in like the RStudio IDE. And now adding a new graphical visualization to the GUI, even if it depends on kind of crazy funky R libraries doing all kinds of wild things, is just really easy, right? So we can just that was a one-liner to generate that particular graph, and there's a lot of other cool graphs you can do with one-liners and two-liners and three-liners and all that kind of thing. So this is kind of the point that I wanted to get to today. I'm happy now. I'm going to have to follow up by putting this in a state that I can make a pull request out of it to go into Studio, and then when that's done, I'll post a link, I'll blog or something, and post the simple instructions to run this command and see the same thing on your machine. Well, maybe we'll need to do a little more work on the live coding between now and then to make sure that we get our sudo available and all that kind of thing. We'll see whether another live coding session is needed to get this into a pull request state merged onto the Studio repository or not. Anyway, thanks very much. Out.